All right, so let's take a look here at questions 6, 7, 8, and 9. And the directions for this section are to factor out the greatest common factor. All right, so we are doing almost exactly what we did with the first set of questions, 1 through 5, except now instead of being given a list of terms, we are now being given an expression. And so once we find the GCF of each expression, we then have to write what is remaining once we pull out that GCF. All right, and I think that'll make a little more sense once we go through these. So let's take a look at number 6, and we have 3z minus 15. All right, well, let's again start with the numbers, the coefficients, and we're looking for the largest number that goes into 3 and 15 evenly. Well, I think you'll agree that 3 is the largest number because 3 goes into itself once and 3 goes into 15 5 times. And how about z? I have a z here in this first term, but we don't have a z in the second term. And so if what you are trying to pull out is not common in each term, then it can't be considered a common factor. So since z is only present in one term here, it's not going to be part of our GCF, our greatest common factor. And so in this case, 3 is the only thing that we can take out. And so now what we have to do is, right behind the GCF in a set of parentheses, we have to put what is remaining after this 3 is taken out. And so what we are going to do is say 3 times what gives me 3z? Well, 3 times z gives me 3z. All right, and 3 times what gives me negative 15? Well, 3 times negative 5 gives me negative 15. And so there is our greatest common factor that we've now pulled out, and right behind it is what is remaining once we've done that. So we've factored this expression. And again, it's a good idea on the test to check yourself. 3 times z gives me 3z. 3 times negative 5 gives me negative 15. All right, let's take a look here at number 7 rather, excuse me. I was looking at this 9. So we're dealing with a 9, a 6, and a 15. What is the largest number that goes into 9, 6, and 15 evenly? Well, I think again it's going to be 3, isn't it? Because 3 goes into 9 3 times, 3 goes into 6 2 times, and 3 goes into 15 5 times. All right, how about w? Do we have a w in each term? Yes, we do, so we can go ahead and take out that w. And then how about x? Is x present in each term? Nope, doesn't look like it. X is only in this first term, so we can't take it out as a GCF. How about this w? We have a w here in the second term, but we don't have a w in the first or third term, so we can go ahead and exclude that. We're not going to be taking a w out. And how about z? We have a z here in this third term, but a z is not present in term 1 or 2, and so z will not be part of our common denominator, so it's just 3w. So now we ask ourselves, 3w times what gives me 9wx? Well, 3 times about 3 is going to give us this 9. Our w is already here, and so the only thing we're missing is the x. All right. 3w times what gives me negative 6wy? Well, 3 times negative 2 gives me that negative 6. We have our w covered, so the only thing we're missing is a y, right? All right, and lastly here, 3w times what gives me negative 15wz? Well, 3 times negative 5 will give me that negative 15. We have our w here already, so the only thing we're missing now is z. All right, if you're finding it difficult to come up with what is remaining after you've pulled out your GCF, you can find another way to figure out what goes in that set of parentheses. And to do that, all you're going to do is take your original expression, which in this case was 9wz, wx rather, excuse me, wx minus 6wy minus 15 WZ. And now what you're going to do is, under each of these terms from the original expression, write the GCF that you found. So we said the GCF in this case was 3W. All right, now we're going to use what we learned in the previous chapter for the previous test, number 2, and we're going to reduce this. And we're going to do that by saying, well, 3 goes into 3 once, 3 goes into 9 3 times. Our W's cancel, and we're just left with x. So 3 times x gives us that 3x. 3 goes into itself 1 time, 3 goes into 6 2 times. The W's cancel, and so we're left with negative 2 times y. Well, that gives us that negative 2y. And lastly here, 3 goes into itself once, 3 goes into 15 5 times. The W's are going to cancel, and so we're left with negative 5 times z gives us that negative 5z. All right, so again, if you don't like, using the method where you say 3w times what gives me 9wx, then go ahead, take your original expression, and under each term of that original expression, rewrite the common factor that you pulled out. All right, let's take a look here at number 8. Well, we don't see any coefficients, do we? So we're not going to be pulling out any numbers. And I have a t here and an s here, so I can't pull either one of those out because they're not common. But I do see that I have a 2 minus m quantity in each term. And now that I could definitely pull out, right? Because when you have a quantity like this in parentheses, it is acting as a single term. And so we have a 2 minus m here and a 2 minus m here. So that will be a factor that we can pull out. And now we can say, well, the quantity 2 minus m times what gives us the quantity 2 minus m times t? Well, the only thing we're missing is t, right? So there's our t. And now again, quantity 2 minus m times what gives us the quantity 2 minus m times s? Well, here the only thing we're missing is an s. And so there you have it. There's our GCF that we've pulled out, and we wrote what was remaining once we did that. But again, if you don't like this method, go ahead, rewrite the original expression that you were given. And underneath each term of this expression, you're going to write your GCF, what you found to be your GCF. And so in this case, let's go ahead and reduce. 2 minus m cancel, and so we're left with just t. 2 minus m and 2 minus m cancel, so we're left with just s, And so here is our final answer. And I forgot to circle here with number 7. All right, and last but not least, let's take a look here at number 9. So we are going to look at our coefficients first, and we're dealing with a 4, an 8, and a 12. So what's the largest number that goes into 4, 8, and 12 evenly? Well, I think it's going to be 4, isn't it? 4 goes into 4 once, 4 goes into 8 twice, and 4 goes into 12 3 times. And again, well, now we have a quantity that's being raised to some power, right? In this case, we are dealing with the quantity x plus y. And since we're dealing with a quantity that's being raised to a power, we know we're going to have that quantity. But what exponent do I use? Well, remember, we take out the largest coefficient we can, the largest number that goes into each of our coefficients. But when we're dealing with our variables, or the powers, we want to pull out the smallest exponent. And so we're dealing with a 6, a 5, and a 7. And so we're going to take out the 5. All right, let's go ahead and to figure out what we are going to write for what's remaining once we take out this GCF, let's go ahead and use the method that we've been using up here. And so we'll rewrite our original expression, so x plus y to the 6th, and then minus 8, x plus y to the 5th, plus 12, x plus y to the 7th, and then we said that 4 times the quantity x plus y to the 5th was our GCF. So we're going to rewrite that GCF under each term of the original expression. to the fifth, and finally 4x plus y to the fifth. All right, so let's see what happens here. And we, again, are going to reduce this, and whatever we get when we reduce is going to be what's remaining. So, well, 4 and 4, those are going to cancel, and then we're left with quantity x plus y to the 6 over quantity x plus y to the fifth. So we have the same base. So what do we do with our exponents? Well, we subtract, or we can say, are we top heavy or bottom heavy? We're top heavy by how many? Well, we're top heavy by just 1, right? Because 6 minus 5 is 1. And so for the first term here, we're going to have just x plus y. And that makes sense, doesn't it? Because you'll remember when you multiply like bases, what do you do with the exponents? You add them. So in this case, we're multiplying like bases. Here's the 4, so 4. And then x plus y to the fifth, x plus y to the first, like bases, so you add the exponents. 5 plus 1 gives us 6. All right, let's take a look here. 4 goes into 4 once, 4 goes into 8 twice. And then we have quantity x plus y to the fifth, quantity x plus y to the fifth. Well, those are going to cancel each other, and so we're just left with a minus 2. And then we're going to have a plus. So 4 goes into itself once, 4 goes into 12 3 times. And we have quantity x plus y to the seventh, quantity x plus y to the fifth. Are we top heavy or bottom heavy? Well, we're top heavy by how many? Well, 7 minus 5 gives us 2. So we're left with 2 times the quantity x plus y squared. So, or excuse me, 3 times the quantity x plus y squared. So 3 times quantity x plus y squared. Alrighty, there you have it. And you could go ahead and leave it just like this, or if you want to, because there's no sign, there's no negative right here to change the sign of the set of parentheses behind you, we can go ahead and if you want to, you can drop this set of parentheses. Oops, not the whole thing, just the set of parentheses, and you'll just have x plus y minus 2 plus 3 times the quantity x plus y squared. All right, and there you have it. And I think that we have done all we need to do for this set of questions. So let's go ahead and we'll stop here, and I will see you at the next set of questions. This is Joe Brownlee with Palm Beach State. Thanks for watching.